Today we will cover about the rules for reflection. So here we go. So first let's lead up to where those rules came about. Over here I have a set of example points. A at 1, 3, B at 2, negative 5, C at 4, negative 3. What I will do next, I will plot those points on a graph. 1, 3, there's A. 2, negative 5, 1, 2, 3, 4, 5, there's B. Negative 4, 3, 1, 2, 3, 4, 1, 2, 3, there's C. First thing we're going to look at is what happens when we reflect this over the x-axis. So this is my x-axis. I want to reflect this 3 points over the x-axis, starting with A. When we reflect, A starts here. It needs to reflect to the other side. So to do that, we count from A to the line of reflection. We count 1, 2, 3. There's the x-axis. We keep counting to the other side. 1, 2, 3. So A prime goes here. Same thing for B. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. B prime. And C. 1, 2, 3. 1, 2, 3. C prime. So those are my 3 points when we reflect them. Let me write them down. A is now at 1, negative 3. B is now at 2, 5. And C prime is now at negative 4, negative 3. Looking at my tables, we can see the pattern that's going on here. Looking what happens to the x, we notice the x stays the same. But looking at the y's, we notice that the y's, positive 3 became negative 3. Negative 5 became positive 5. The y's changed signs. So from here, dropping down to part C, which of the following rules represent a reflection over the x-axis? It's going to be choice, rule number 4 right here. This rule tells me x stays as x, it stays the same, y changes sign. Y becomes a negative y here. Now, the negative in this rule does not mean change y into negative. This negative means change the sign of the y. That comes from up here. I'll use B as an example. Following the rule, x stays the same. So we have 2. Following the rule, we put a negative in front of that y. There's a negative. But here, negative 5 already has a negative. So if I put a negative in there, it becomes a negative negative 5. And as we know, negative negative makes it a positive 5. So that minus sign in there means change the sign. Alright, let's do next now, reflect over the y-axis. Going back to my original points in purple. Reflect over the y-axis. This right here is the y-axis. So when we flip, I flip from left to right. So starting with A, 1, keep counting, 1, A prime, B, 1, 2, 1, 2, B prime, and C, 1, 1, 2, 3, 4, 1, 2, 3, 4, C prime. Now going ahead and writing down those points, A ends up at negative 1, 3, B prime ends up at negative 2, negative 5, C prime ends up at 4, positive 3. 4, 3. So comparing my original table with the table over the y-axis, purple with orange, on the x side, 1 becomes negative 1, 2 becomes negative 2, and negative 4 becomes a positive 4. The x changes signs. On the y side, 3 is 3, negative 5 is still negative 5, and here 3 is still 3, it stays the same. So dropping down to part D, which of the following rules represent a reflection over the y-axis? Which of these rules had it where the x changed signs and the y stayed the same? So that's going to be rule number 3. X became a negative x, the sign changed. A y stays as a y. So far we have covered 2 different rules for the reflection. Starting with my original x comma y, if we reflect over the x-axis, my change becomes x negative y. If we reflect over y-axis, what we have is negative x comma y. Alright, we'll keep going and discover 2 more rules. Next up, we're going to take a look at what happens when our line of reflection is y equals x. So again, I have these points to use as my example. So let me plot these points. A is at 0, 0. B is at 2, negative 1, 2, 3, 4, 5. And C is at negative 1, 2, 3, 4, positive 3. A, B, C. It now tells us to reflect over the line y equals x. The line y equals x is represented by this diagonal line. Okay, that diagonal line. And let's go ahead and reflect. When we are reflecting, we now have a diagonal line. That diagonal line changes things. So I'll use the example. My point C over here, when I fold, it ends up being in this spot. It's not directly below it, it goes diagonally. Again, C over here, it folds, it lands here. So the way we do that is when you count. From C, you count 1, 2, 3, 4, 5, 6, 7 to hit that line. You then change directions. 1, 2, 3, 4, 5, 6, 7 to find C prime. Do the same for B. 1, 2, 3, 4, 5, 6, 7. Just so happens to be 7. We change directions. 1, 2, 3, 4, 5, 6, 7. B prime. A is special. It's on top of the line. So it would be like if my point was right here on the line itself and I fold it, it doesn't go anywhere. It's on top of the line. So A prime stays right there. So now writing my new sets of points. A prime stays at 0, 0. B prime is now at negative 5, 2. And C prime is now at 3, negative 4. Looking at my pattern, what we notice comparing the x's and the y's for both tables is the x and the y switch places. The 2 and the 5, negative 5 switch places. The negative 4 and the positive 3 switch places. So x and y switch. So dropping down here, the rule that shows x and y switched is choice B. X and y switched. Alright. So going over here. When we reflect over y equals x, the x and the y switch. Alright, we have one more rule to figure out. Next part, before we figure out our last rule, is to determine the line of reflection. How can we find the line of reflection? What kind of special properties does it have? So I have here two figures reflected over this line. To discover the properties of that line of reflection, what we're going to go ahead and do is connect these points. Connect the points that correspond with each other. So let's go ahead and connect C with C prime. Let's connect B with B prime. And A with A prime. And let's see what kind of properties can we observe. First, because the line of reflection, that mirror, is in the middle of the two figures. These right here are all midpoints. It's in the middle. Midpoint of A and A prime, midpoint of B and B prime, midpoint of C and C prime. Next, we take a look at the angle it forms. Sticking a protractor over here. Here's my first angle. I match it on the line. Here's my second angle. It's a 90-degree angle. 90-degree angle. 90-degree angle. That line of reflection is always perpendicular to those segments. So a property that we can observe, it crosses through the midpoint, meaning it bisects those segments, and it forms a right angle, and we have a special word for that. The line of reflection is a perpendicular bisector to the segment that connects A with A prime, B with B prime, C with C prime, so on. So this line of reflection is a perpendicular bisector of that segment. It's a perpendicular bisector of this segment, and a perpendicular bisector of this segment. So this is one of the ways we can figure out if our if our line of reflection is drawn correctly. If you were to connect the matching points of the image and the pre-image, then the segment you create, this segment right here, has to be perpendicular with your line of reflection. If it is not perpendicular, that means your line of reflection is drawn incorrectly. Next up down here, how can we find line of reflection on a graph? So we said it's a midpoint, right here, midpoint. So on a graph we can find midpoints. Using x and x prime as my example, going from x to x prime, I move over 6 and down 6. Because it's a midpoint, midpoint means halfway, I go half of 6, which is 3. Starting from x, 1, 2, 3, 1, 2, 3. There's my midpoint. Again, 1, 2, 3, 1, 2, 3, midpoint. Doing the same for z. 1, 2, 1, 2. This goes down 2 over 2. Halfway would be 1 and 1. There's the midpoint for z. Midpoint for y and y prime. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 10 over 10, so halfway would be 5 and 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's my midpoint. Now the line of reflection going back up here crosses through all those midpoints. So what we can do is to draw a line connecting all those midpoints. And there's my line of reflection. Last step is to find the equation that solves for the line of reflection. Remember, equation of a line is y equals mx plus b. Looking at my line, we want to first figure out the slope. Going from one point to the next, we count rise over run. Rise is 1, 2, 3. Run, 1, 2, 3. So rise is 3 over 3. Because my slope, my line is going down from left to right, the line goes down, it's a negative slope. So negative 3 over 3x plus my y-intercept. Where did my line cross the y-axis? My line crossed the y-axis at 0. So y equals negative 3 over 3x plus 0. Cleaning this up a bit algebraically, negative 3 over 3 simplifies into a negative 1x plus 0. And mathematically, we don't need to say negative 1 in front of an x. We just call it negative x. And we don't need to say plus 0. So y equals negative x. Last is, how can we use this to find the rule for the line y equals negative x? So I will use x and x prime as my example. X, the point x, is at negative 1, 7. X prime is at negative 7, 1. Looking at these two coordinates, we notice a pattern here. The pattern goes: the x and the y switch places and switch signs. So for the line y equals negative x, the rule is x comma y turns into negative y comma negative x. And that is the last rule for reflection. So here you have the cheat sheet, the 4 different rules for reflections over the 4 lines we're interested in, over the x-axis, over the y-axis, over y equals x, and over y equals negative x.